So if these are the perpendicular bisectors, well then they all need to be perpendicular. And if they're bisectors, that means they're bisecting these sides. Which means what about point D, point E, point F? They're all midpoints. They have to be midpoints because these are perpendicular bisectors. Okay, let's start answering these questions then. Number 13, it says, says, find the length of segment AG. What's the length of segment AG, and how do you know? It's 25, because the length of, this segment AG is representing the distance from one vertex to the circumcenter. Well, we know that that circumcenter is the same distance away from all of the vertices. So it's 25 units away from point C. That means it's 25 units away from point B and from point A. The next one. Determine the length or find the length of segment BD. How do you know it's 20? How do you know they're congruent? Because it's a perpendicular bisector, meaning point D is your midpoint. Number 15, find the length of segment CF. Find the length of segment CF. 24. 24, for the exact same reason. This is the perpendicular bisector, therefore point F is the midpoint. So if that's 24, that's 24. 16, determine the length of segment BG. 25, same reasoning as number 13. That's representing the distance from a vertex to the circumcenter. The circumcenter is equidistant from the vertices. Number 17, determine the length of segment CE. 15, because point E is a midpoint, because that's the perpendicular bisector. And then number 18, the last one. We've got, what is the length of segment AC?
48.
48. The length of segment AC, which is this whole triangle side, is 48, because this is 24, that's 24, add them up. 48. So you need to be able to take this information, these given information, and mark up your diagram. Because once it's marked up like this, all of these questions are cake. Really easy. All you gotta do is just look at your diagram, but you have to know where to put your appropriate marks of congruency, and so on and so forth. Okay, I just did an insane amount of your homework. So on page 88, which was before this, 1 through 12, I did number 1, I did number 4, I did number 5, I did number 6, and I told you exactly how to solve 7 through 12. And then on page 89, which is currently being projected on the board, 13 through 18, we just did every single one of those. So we're going to move right along in this material, moving to the angle bisectors. Moving to the angle bisectors. We're going to keep going with the same theme of adding notes to our homework so that we have our notes right there on our homework. On page 91, this deals with angle bisectors. And so that is why at the very tip top of the page I wrote angle bisectors. Now I don't think it's necessary for us to have to write the definition of angle bisector. Is that safe to assume? What is an angle bisector? Yeah, it's a line that bisects an angle. So if you need to write that, if you need to write the definition of angle bisector, then please do so right above here. An angle bisector is a line that bisects an angle. And we know that what it means to bisect, cut into two congruent parts. Yes, sir, Tim.
Is that in center?
Yes, that's correct. So this page is dealing all about the angle bisectors. The POC, or the point of concurrency, like where they're all going to meet, is called the in-center. I-N, that should be a C, sorry. I-N-C-E-N-T-E-R. The POC is called the in-center. And the in-center is always going to be inside your triangle. Always. It's always going to be inside your triangle. Well, what's unique about this in-center? Something's got to be special about it. Well, the in-center is equidistant. The in-center is equidistant, and then I put an open set of parentheses. I put an open set of parentheses. And then in that set of parentheses, this may be easier or not. When I say equidistant, we're talking about the distance from a point to a line or to a segment. So that has to be the perpendicular distance. The incenter is equidistant. You have to be talking about the perpendicular distance from three sides of the triangle. Your incenter is equidistant from the three sides of the triangle. So the circumcenter was equidistant from the vertices. Now this guy, the incenter, is equidistant from the sides. And you have to be talking about that perpendicular distance. The next thing, this sentence right here, it reads, any point on the angle bisector is equidistant from the sides of that angle that it's bisecting. And again, equidistant, you have to be talking about that perpendicular distance. Because that is the shortest distance from a point to a line. And we've discussed this before in this class many times. There was at one time, back way back when, where there was some dudes sitting around and saying, or girls as well, what's the distance? How far away is point A from this line? We need to know the distance between these two objects. How far away is it? Well, someone came up and said, well, I'm going to measure from here to here. That's my length. And some guy was like, no, you idiot, don't go to the left, go to the right. That's better. This is the length. And some other guy said, no, you were all wrong. That's too much. This is the distance. So they had to come up with a universal law. They had to say, hey, like, one of us has got to be right, and there has to be some universal thing that we're all going to follow, because we need to know how far away is this point from this line. And what we chose is, if you're talking about the distance between a point to a line or a ray or a segment, it has got to be the perpendicular distance. That's the distance that you measure, is the perpendicular distance. It happens to be the shortest distance from a point to a line. That's why in the notes, that's why you should have wrote down, is you've got to make sure you're talking about that perpendicular distance. If you don't know it's the perpendicular distance, then you could be talking about anything. And I remember that we've discussed this in this class because I said that when you go to the doctor and they measure how tall you are, the point on your head to the ground, like they don't put a measuring tape here and then go all the way over there and say that you're 10 feet tall. It's the perpendicular distance, because you are perpendicular to the ground. That is the height, that is the distance that we are looking at. So when you're dealing with these, the incenter, you got to make sure you're dealing with that perpendicular distance. So if we go through a couple of these, number one says use the information in the diagram to find the measure. So whatever measure they ask. So here they're asking for a length. Here they're asking for a measure of an angle. And here they're asking for a measure of the angle. So we're going to have to be able to solve all parts of these diagrams. First off, in item 1, what can you tell me about ray BD? So we're looking at ray BD. What can you tell me about that ray? It's the angle bisector. How do you know that that is the angle bisector? Because it doesn't say anything in the instructions. Keep going, Sam. Yeah.
congruency marks are like, yeah.
That's it. There's marks of congruency. That's it. There are marks of congruency telling us that this part is congruent to that part. So without a doubt, this is the angle bisector. It's clearly bisecting that angle. Well, if that's the case, then we're going to use this fun fact that we wrote like all the way down on the page, or at least I did. I'm not sure where you wrote it. Point D is on the angle bisector. We all agree? So if that point truly is on the angle bisector, then what do we know about it? What do we know about it?
It's equidistant to the sides of the angle.
Thank you, Sam. It's equidistant from the sides of the angle, meaning the perpendicular distance, which they have told us, this is the perpendicular distance, so we're good. It's equidistant. So what's the length of AD? 19. Because it's equidistant, the same distance away. Item 2. Look at item 2. Do we have the marks of congruency in number 2 like we did in number 1? No, we don't. So right now, just by strictly looking at the diagram, we're not sure if this angle is being bisected. But there's other ways to determine if it is being bisected. We have to use the thing that I wrote down here. That if we can show that a point is equidistant from the two sides and it's on that ray, that means it has to be the angle bisector. So point H, it is clearly on this ray. And we're trying to convince ourselves, we're trying to prove that this is the angle bisector. Well, if that's the case, then what would have to be true about point H? If that was the angle bisector, then point H would be what?
Equidistant
From what?
to the sides of the angle.
Equidistant from the sides. Is point H equidistant from the sides?
Yes.
Yes, it is. Because this is the perpendicular distance. You gotta know you're talking about the perpendicular distance. And it shows that those are congruent. So yeah, point H is equidistant from the two sides of the angle. Therefore, what can you say about ray FH?
Angle bisector.
It is the angle bisector. You have proven a different way that that is the angle bisector.